Alright, honors geometry, fun talk Friday. Students will be able to, you guys will be able to use angle measures and postulates and theorems to prove lines parallel. Section 4.3. So what happened was, last section, like it says at the top of your notes, what we did was we started with parallel lines and we worked towards the angles. We started with parallel lines, we worked toward having our angle relationships. Now we're going to go the reverse direction. So now we're going to go the reverse direction here, okay? So now we're going to start with angles. Stop. Now we're going to start with angles and we're going to work toward parallel lines using the angle relationships to get us there. Okay? So last time what we did was we had said, hey, these lines are parallel. Now we can find the angle measures using the angle relationships. Today we're going to go reverse. We're going to say, hey, here are the angle measures. Now let's use those relationships to prove lines parallel. Okay? We're just going the opposite direction, okay? Now, hey, do you guys remember how we had all of those inverse, converse, contrapositive, those kind of things from before, from chapter 2? Yeah. Hey, guess what? No. Converse is coming back, guys. Okay? No, which one was converse? Okay, not the shoe brand. Which one was converse?
No.
It's where you took
opposite.
the opposite. Which way? You switch the order. Very good. The first part is last. The last part is first. Okay? So, converse the corresponding angles postulate. Well, if we go back to what the corresponding angles postulate said, it said, hey, if two parallel lines are cut by a transversal, corresponding angles are congruent. So now if we do the converse, we want to switch that around. If two lines are cut by a transversal and corresponding angles are congruent, and if you want, you can just say CORR, period, and congruent, you can do the symbol. If two lines are cut by a transversal and corresponding angles are congruent, then the lines are parallel. So we're switching the two around. Before we said, hey, if the lines are parallel, the corresponding angles are congruent. Now we're saying, if the corresponding angles are congruent, the lines are parallel. We're switching them around. We're making the converse of the statement. So we're saying, hey, if we have corresponding angles congruent when these lines are intersected by a transversal, then we know these lines are parallel by this converse of the corresponding angles postulate. It has to be that way. Okay. So let me say here, okay, somebody tell me set of corresponding angles. Justin.
The two bottom stars?
Yeah, the two bottom, like these two?
Yes.
No. Okay. Hey.
The one in the angle line D, and then the one like vertical that, so across the middle of it. No. Yeah.
No, it has to be vertical angles. Taylor, where would it be from here?
C.
This one? Very good. Corresponding angles are kind of in the same spot there, okay? I want you to highlight those two stars, okay? I want you to highlight any two corresponding angles there. We don't care what corresponding angles you do. I want you to highlight some corresponding angles there. That way we know as we look back on this set of notes, okay? As we look through this, I'm sure you guys spend every night studying, okay? That way you guys know, hey, these are the corresponding angles here, okay? That's an example of corresponding angles you can see again.
What else would I be doing with my social life?
Exactly. You have a social life?
I don't have a social life.
Okay.
I don't have one either.
Yeah, I was quite alarmed that you have a
My
social
parents are
life,
so
okay?
strict at it.
What?
Larry sometimes stool.
That's, I should stop doing that. Okay.
My straw?
Okay. Yeah.
I can't see behind.
How strong?
Kind of reminds me of some twins I know.
Does the door open itself or you just not close it all?
Who? Oh, yes, the nuts. They are. Yeah.
Does the door?
Any twins involved in cross country are probably just
No, bro, you have to for it.
Okay, so, anyway, okay, questions on this?
No.
Okay, now guess what? We're going to have some more converses as well, okay? And I want you to write this in there. This part in blue, that's not in there for you. I want you to write it in. I wrote them in myself too, okay? So make sure we're writing converse and corresponding angles postulate. We can shorten this down, guys. Okay, we can shorten this down. We can say, that turned out really poorly. Let me try that again. Converse of corresponding angles postulate. Okay? You can shorten it down like that if you wanted. Okay? Fantastic way to write less and still mean the same thing. Note taking, life hack. Okay? Charlie, you need help reading that? Okay. CUNV, period. So I just did the first four letters. First four letters. I did the symbol. And I did the first four letters.
Do you ever just like look at your notes and you're like, what was I thinking? Why would I write this? Like, what was I thinking?
Sometimes.
No.
But you get better over the years and write better notes. Okay? Question on that. Okay, we're going to go on to the next one here.
Fall over and you're gonna crack your head.
So the next one, converse of alternate interior angles theorem. Let's write this, please. Okay? Here's how you shortcut it. Con of alt int equals THM. Okay? That's how you shortcut that one. So go ahead and shortcut that one and write it out, please, and thank you.
It'd be hilarious if Mr. Howard said just like he said, and you're like a frog.
I mean, I've done more embarrassing
He
things.
definitely have a problem with it.
Like what?
You're like
No, you
going
don't.
back in all of my like. He had a problem when my feet were like this.
Yeah, that sounds about right.
Because
He wouldn't have a problem with this. He'd be okay with it. He'd
You're
be
like
weird.
breaking all the rules that I learned in elementary school.
Why do you care how I sit in a desk? It's school's about being comfortable.
No, it's not.
school is 8 hours of torture.
Yes, the school's about making you guys cry.
So I gotta make
Okay.
myself
If two lines are cut by a transversal, and what kind of angles?
Alternate interior.
Oh man, alternate interior. You guys are bright. Okay, alternate interior angles are what? Then the lines would be parallel. But congruent. Okay, I don't know what my voice did there. Human round two, I guess, didn't stop. Okay,
I miss you not
No,
having
you
like, a little bit of
twice.
facial hair. It's kind of sad now.
a little bit of what?
I wish you would shave it again. I enjoyed it.
How do they grow back so fast? That's like.
I'm a girl, man.
Well, that's I beg to differ.
Wow, interesting.
You
okay.
sure do not act like it.
Legally, he's a grown man. Mentally,
Sure, I'm basically 12. Okay.
It looks kind of
So-
weird on your neck though.
Yeah, I normally cleaned it up a lot, but like no shave November, just letting it go. Yeah, I will. At the end
I
of
actually
November,
broke
December.
their shave November.
No,
My armpits were just like,
thank
nope,
you. I don't like
no,
to do
my
that.
shave.
Okay, tell me, someone tell me some alternate interior angles here. Kevin.
The A star, yes, and then the D star.
Very good. Those could be two alternate interior angles. You also pick the other pair. Cool beans, okay? So mark those or the other pair. Really don't care. That way we know
That
that's what happens, okay? Yes. Okay. So, anyways, okay. Converse of alternate interior angles theorem. Once again, we took the alternate interior angles theorem, saying, hey, two lines cut by a transversal. Lines are parallel. Alternate interior angles are congruent. Flipped it around. If alternate interior angles are congruent, then the lines have to be parallel. Okay.
Do you ever pass someone
Yeah, you can borrow someone else's, right? Okay. Then let's look up here. Oh, what do we see, guys? We see the next one.
Can you erase all of that, please? It's gonna frustrate me.
Okay. Converse of
Sorry.
alternate exterior angles theorem. Okay? So please write that one in on your third one there.
Yes.
Okay? And I'm guessing you guys can figure out what goes in those three blanks as well.
What?
Rowan, you can't guess it? Dang it! I really had high hopes that you specifically could, okay? Yes. Okay. What kind of angles are we going to talk about? Two lines are cut by a transversal, and what kind of angles? Great.
Alternate exterior.
Very good. Alternate
No way.
exterior. No way. Way. Okay. Alternate exterior angles are what? Congruent, because they're supposed to be congruent, okay? Then the lines are parallel. So if alternate exterior angles are congruent, the lines would be parallel. Have to be. Okay? So what angles could I be talking about here? Okay, Alyssa.
Listen.
Okay, perfect. Up here. And down here.
Wait, I was wrong for that one. I didn't know it was going
That
to
sucks.
Would it be that one?
And if Anybody still need this? Questions on this one?
Is the next one gonna be
It's gonna be same side interior angles, okay? So two lines are cut by a transversal, and what kind of angles we're talking about this time?
Same side to yours.
Same side interior.
Where did the converse of this part come
Of same side int angles. What are we asking?
Why is there converse? Like, what is it even for? What is it even doing?
Prove the lines parallel. But sometimes we don't know the lines are parallel. It's good to know the lines are parallel. And then if we know the lines are parallel, we can find out so much other stuff. Melissa.
The one with the converse of opposite exterior angles, that is
A theorem. Yep. All of them are theorems except for corresponding angles.
Which what, dude?
Which is a postulate. Because that's one we had to start with, to be given, and then from there we can prove all the others true. Okay? Same side interior angles are what? Then the lines are parallel. Supplementary. Thought I'd trick you guys, but you got it.
Sup?
Okay? That's what happens. You guys are my best and brightest third hour classes here. Okay?
It's you.
Well, if you think about it, if you did say this year, that could like makes people not third out last year.
It's true.
Well, are we
Except for I didn't have a third hour last year. Okay? So what
we are
angles would I
better
be
than
talking
the
about here?
The same side lines and then side.
A and C, cool. Could I have also said B and D? Sure.
No.
Oh, okay.
Why not just top, left, bottom then?
Sure. Anybody still need this or have a question on this part? Flip the page.
Oh my goodness.
We have one more. Hey, what do we think's gonna be underneath this box, guys?
Side exterior.
Man, I bet I fooled you with that. Okay, come up, same side, X angles. Hey, Evan, if two lines are cut by a transversal at blank angles, go ahead and tell me, buddy.
Same side and exterior.
Yeah, same side exterior angles, okay? And what would those same side exterior angles have to be for the lines to be parallel? Supplementary.
Sup?
Oh, okay, trying to slide in the DM, say sup. Yeah, right? Oh,
You can't slide in TNs.
that's true.
He doesn't have
That's fair.
No, also the fact that he has a girlfriend.
More importantly.
But you could still slide into
Already did. Okay, anyway.
group.
Oh, I'm glad that you made the first move.
Yeah. Actually, no, she came up and talked to me first.
I'll just
Yeah,
Wow.
we'll talk,
Mr.
yeah.
Cousins.
No, I was like too happy being single to like be like, nah, I'm not gonna go talk to her. I thought she was cute. But I was like, I'm just too happy to be single, being single right now. And then she came up talking about it.
Where did
It
that
might be changes.
go? Where did you girl?
The church. Yeah. Straight up, I met her mom before I met her, and like her mom's like,
for a really long
her mom like told her for like 3 weeks, 4 weeks in a row, like, Hannah, go talk to her. And she's like, no, mom, that's weird. And she did.
I cried today.
So anyway, what angles did I talk about here?
The same side
Perfect.
that are inside or outside.
Yes.
Same side transversal, both exterior.
Can you gobble like a chicken? Or a chicken, a turkey?
No.
Neither can
I can also sound like Boss Mask from Star Wars Episode 1.
Do it.
Fun fact.
Yeah.
Okay, continuing on. Ah!
Jocelyn, how do you know I
Name the angle relationship and find the value of x, which will make A and line A and line B parallel. So we're saying, hey, if these lines were to be parallel, what would x have to equal? We first say what kind of angles are these? They're corresponding angles. Okay. They're corresponding angles, and so if these I'll make you start. If these are corresponding angles, which they are, for these two lines to be parallel, these angles have to be what? Congruent. They have to be equal measure. So in order for these lines to be parallel, these angles would have to be congruent. So we're saying, what value of x makes that true? So we have to set these equations equal equal to each other, set these equal to each other, and solve. And that'll say, hey, what value would make this true? So we have 3x equals 60, and as many of you have told me, which is awesome, x would equal 20. So we're saying, name the angle relationship used, corresponding angles. Okay? Find the value for which x, find the value of x that'll make these lines parallel. X is 20. So only when x is 20 would these lines be parallel. If x was even 21 or 19, these lines would not be parallel because those angles would not be congruent. Does that make sense?
Sure.
So we basically doing the same thing.
Yeah, it's just it's just the opposite, the flip side of it. We're just,
Oh wait, because these used to be or
proofs.
No, it's the same thing. So how's it? There's no proof.
no, it's not.
Because we're going backwards. Because we're saying, okay,
It's the
we
same
don't know
thing.
these lines are parallel now.
Yeah.
So let's say, okay, what would make them parallel? So what kind of angles are these?
Same side.
Do we have to
A,
write that?
side.
Can they also
Name
do
the angle
linear?
ratio. Yeah, I guess so.
Yes, they could also do linear.
Sorry, I didn't hear what you said. Nope, they're not a linear pair.
Why not?
Linear pairs have to be adjacent. They have to be next to each other.
Why not?
They have to be like literally touching. They have to have a vertex share a side. These don't share a vertex and side. So same side interior angles.
You should throw it with your foot. Yeah, why aren't you doing it with your foot?
Skill.
Happy? Okay. So how could we figure out what x would have to be for these lines to be parallel?
7% equals 180.
Add them to 180. Because if these lines are parallel, these have to be supplementary. So we're saying, well, let's force them to be supplementary. And then solve to figure out what x would be for these to be parallel.
Wait, I was- Why would that one be each other?
Corresponding angles have to be congruent in order for the lines to be parallel.
Does it say that on the chart?
Yes. It also says it in this part. We just did right
And
before
then
this.
that one says it has to be
Yep, supplementary, yeah, which is the same. So we solve x equal to 50. So when x is 50, these same side interior angles are supplementary, which would make the lines parallel. If x was 51, if x was 49, if there was any other number besides 50, these would not be supplementary, and so these lines would not be parallel. And they would still be same side interior angles, but the lines would not be parallel. Because they're only parallel when the angles are supplementary. And vice versa, angles are only supplementary when the lines are parallel.
Wait, hold on for like 1 second, please. 1 minute. How?
Would you put your arm down, please? You don't even have a watch.
How do you know that?
Because I'm looking at your arm.
That's a little weird grading. I'm just
Yeah. Have a respect for privacy.
What if he actually doesn't have a watch?
Yeah, what if I have a watch and you just can't see it?
I can see it.
What if he
I
has one
can see
drawn
that
on
you
his
don't.
thing and it works? Maybe
Yeah.
he's a robot. Have you thought about that?
Yeah, beep, boop, beep, beep.
Robots are funny.
Oh.
That's better than I'm a robot. I'm sorry, are you a bot?
You know what time it is?
No, I know.
No, he's waiting a minute.
He's holding on for a minute.
So we could just like tell you to hold on
Okay.
for 5 minutes.
Continuing on to the next one. Okay? What kind of angles are these?
Alternate
Okay.
interior angles. They're congruent. So you
And these would have to be congruent if the lines are parallel. So we set them equal, and we say, okay,
90.
x would have to be 90 in order for these to be congruent. So if x is 90, these alternate interior angles are congruent, and then the lines would have to be parallel by the converse of the alternate interior angles theorem. Okay? The regular alternate interior angles theorem proves the angles congruent. The converse proves the lines parallel. Okay? The regular one gives the angle measure. The converse goes the other way. Okay? Then we look at number 4. It's not numbered, but the fourth one. What kind of angles are those? Alternate exterior angles. And what would alternate exterior angles have to be in order for these lines to be congruent? Okay? we set them equal to each other.
5.
And x would have to be 5. It needs to be congruent. So as long as x is 5, these lines are parallel. If x is literally any other number, they're not parallel. If x is literally any other number, they're not parallel. The lines are not parallel. These are still alternate exterior angles, but the lines will not be parallel.
What if the number was 5.0?
It's the same number. If it was literally any other number, if x was literally any other number, these alternate exterior angles will not be congruent, and so the lines wouldn't be parallel. Okay, let's say if I plug in 5 here, okay, we get 20 minus 22. That's not I need to change this problem. No, this is negative 2 degrees. Ooh, that's not possible.
Also, why did you like half erase something there? And part of the line.
So,
Oh,
right.
it does.
Okay. But anyway, if it was a different number, these wouldn't have the same measure. Let's say I plugged in 7. Okay, so you get 28 minus 22, that'd be 6. And then you get 21 minus 17, so I get 4. They're not congruent. If they're not congruent, the lines are parallel. Yeah, that'd be fine. You can do that. Okay. It's a good idea to add plus sign. That'd be a simple fix.
Yeah, that's fine.
Okay, that's why we paid the big bucks. Hey, here's one, guys!
I know the first one.
Proof examples!
That's so cool.
Free height, okay?
Go.
Okay, so, we're given that two angles are congruent, we're trying to prove that two lines are parallel. Hey, that's what we've been talking about this. Okay? Grayden, what's our first statement?
Angle 8 is equal to angle 2 is
Congruent to angle 2.
I don't know, your line sucks.
What's our first reasoning?
Given.
Given.
That was a hard
Okay? Is there another? Those are two freebies, aren't they?
one. Yes.
Yeah.
Is there another freebie here?
Yes.
Yeah.
What is it?
L is congruent to N.
L is congruent to N. Or L is not congruent. Parallel to N.
That is not an L.
That's our second statement. It is an L.
That's a
Take
lower
the L. Okay?
Take the L.
Okay. So we should have 3 out of 4 here are freebies, really. If we analyze for a second, 3 out of 4 of these are freebies. Our given is always going to be our first statement and first reason, and whatever we're trying to prove is going to be our last statement. So there's only 2 statements there.
And that's why you don't stand
That's all we do. Okay. So let's mark our information. Angle A is congruent to angle 2. What kind of angles are these? Alternate exterior angles. So in order to prove the lines parallel, what would we use? Close. Alternate exterior angles theorem would say, hey, if the lines are parallel, then these are congruent. So what goes the other way? The converse. Converse of alternate exterior angles theorem. So because we're proving lines parallel, we have to say it's the converse. The regular alternate exterior angles theorem proves angles congruent, because it's talking about angles. The converse, though, proves the lines parallel. So if we're trying to remember which one we have to use, think about, well, what are we proving? Are we proving angles or are we proving lines? If we're proving angles, use the normal one. Let's talk about angles. If you're proving lines, you have to change it up to make it not about angles anymore. Okay? Questions on that one? Let's go to number 2. Wow, 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 wow. Okay. Right? No, one of my other classes was telling me that too. Rowan hates that idea. Means I should do it more. Okay. So,
I really would.
this is going to be a 2-step proof. I'm going to tell you that guys right now. 2-step proof. So, we should already know 3 of the 4 blanks.
How do you know if it's like 2 seconds?
I'm telling you this time. We'll get more used to it, so we'll get better at it. No, hopefully. Okay. So what's our first statement here? At angle 7 is supplementary to angle 2. What's our first reason? Given. Wow, 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 wow. Okay. What's our second statement? Perfect. You got 3 out of the 4 blanks filled. If this was on a test or a homework assignment, hint. Okay? Should we be able to get 3 out of the 4 right without even knowing what we're doing?
Yeah.
Yes! Okay? Okay? So our last reasoning, well, we have to look at what are angles 7 and 2. What kind of relation do those have?
They're, like this.
Same side.
Very good. They're same side exterior angles. And our same side exterior angle is supposed to be supplementary for the lines to be parallel?
No. Yes.
Yes. Okay. So how would we prove it?
Converse.
Converse, because we're proving lines. Yeah, of the same side exterior angles theorem. Okay? So we say, hey, what kind of angles are we talking about? Same side exterior angles. What are we proving? Lines, tack converse on. Boom. Mic drop. Yeah. But it will. Okay. So on to the next one. Okay, this one's a 3-stepper. And we'll see why. Okay. I think we all know our first statement though. What would that be? The given. Measuring angle 4 is equal to 62 degrees, comma, measuring angle 5 is equal to 118 degrees.
I thought when there were 2
You could if you want, but you don't have to.
There is 2 different.
There are 2. Well,
Oh my goodness, I've done double.
and our reasoning is given. So you can put them in 2 different steps if you want to. That is, make it 4 steps instead of 3. But it'll be fine. I'll talk about that more in a moment. Okay. And we're trying to prove L is parallel to N. So where would that go in this 3-step proof? Step 3. Okay. So we still know 3 of the blanks. You have 3 to go now. Okay. So we're told that the measuring angle 4 is 62 degrees. Measuring angle 5 is 118 degrees. Wait, what's that make those 2 angles? They're what now? Supplementary. They add up to 180. Okay. So we can say angle 4 and angle 5 are supplementary. Going back to chapter 2, how do we know that 2 angles add up to 180 are supplementary?
No.
Because that's the definition of supplementary.
Very good. That's the definition of supplementary. That's exactly what the word means. Thank you. That's the definition of supplementary. That's what it means. And you can't force it closed, otherwise it's going to fall every time.
You should get some duct tape. I just watched 4 people jump it.
Okay. So now, if these are supplementary, how can we prove these 2 lines parallel? Converse of what kind of angles are these if they're same side interior? But in order to use this converse, we first had to say that they were supplementary. Because in order for these lines to be parallel, same side interior angles have to be supplementary. So we first had to say they were supplementary, which is the only reason this is a 3-step proof instead of a 2-step. And it's because instead of starting with them being supplementary, we started with their angles, which told us they were supplementary. Alyssa.
Isn't saying that angles technically saying that they're supplementary? That's how we know.
Say that again.
Isn't telling the angle measures and showing that they're supplementary the same thing?
Technically not. They're technically 2 different steps. So a lot of times mentally we combine those 2 steps because we say, we read this and we say, oh, that means this. But we're actually taking a step. Yeah, good question. Just like if you see like, you look outside, you see the sunlight, right? Now, then from there we know, oh, it's daytime. But if you look outside, you don't know it's just daytime. That's not the first step. You have to go through that step there. But mentally, we can't skip that a lot of times. But in a proof, we have to break it down and say, well, I know it's daytime because of the sunlight. Yeah. Okay. Going on to the next one. Okay. This is another 2-stepper. I want to see if you guys can try this one.
I did.
At the very least, you should be able to get 3 of the 4 blanks, right?
We should try the next 2.
The next one's a 4-stepper.
Is it?
Yes.
How is it a four step?
That's definitely.
Trust me, it is.
Impossible.
I did it 3 steps, so you guys tell me what I did wrong.
I love doing that. Jason?
No, I definitely did that right.
Wait, are they?
That makes sense. Okay, go.
All I hear, like I'm not even like looking at anything, is like yeah.
Raise my hand.
Yeah.
They like
Hey, we're gonna talk about this one up here now. Angle 1 is congruent to angle 2. P is parallel to Q. Given. Converse of alternate interior angles. Wow! 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 That sounded like a game show, didn't it?
It did, yeah.
Yeah.
Like wheel.
Oh, fortune. Okay,
Yeah.
question on that.
Why did you erase your board?
What?
Oh,
Oh.
you get ready for next week?
But why not do it next week? Maybe I wanted to see what we did this week. Because I forgot it all.
I'm not surprised. Okay, let's look at this 4-stepper.
This is a 3-stepper. How do I know? Because you don't have numbers. Isn't that really frustrating? Will like my homework have numbers? Otherwise I'm
Oh, probably one more.
Dude, are you right?
Fine, we'll do all 4 of the rest.
Yes.
Oh, that's what I thought, John. Yes.
They're really
Check the SU at the door.
Why are we at the hospital? Oh, wait,
Hey.
no, no, no.
Can we combine these givens into one step? Yes. Because otherwise it'd be 5 steps. So if you want to make this a 5-stepper, you can. You just have your givens as the first 2 steps. Otherwise, you can say M is parallel to N. And we can say angle 2 is congruent to angle 3. That's all one given if you want. Okay? If you want to separate it into 2, you're more comfortable with that, it's a 5-stepper. And every step's just one further down than what I have it. Does that make sense?
yes.
Oh,
Okay.
wait, but then you're gonna. Oh.
I still think I'm right.
So if you
No,
use
you're
2
not.
steps for your given, you're going to use an extra step compared to what I do. Now that's wrong. Okay? Let's mark this. Angle 2 is equal to angle 3. I think it helps us to mark it. Now we're trying to go from this to prove that A and B are parallel. We already know M and N are parallel. Okay. Is there anything else we can gather, knowledge-wise, from these 2 lines being parallel? Amber. 1 and 2 are what?
We're not parallel current.
Congruent. Angle 1 is equal to angle 2. How do we know that? What's for justification there? What kind of angles are they? Yeah, alternate interior angles. And because we're proving angles,
It's common.
we don't have to use a converse. We use a normal one. Because we're proving angles congruent in this step, we're using the regular alternate interior angles. If we were proving lines for this step, we'd use a converse. But we're not. We're using angles. So we use a regular one, which talks about angles. Okay? So now, if we know angle 1 and 2 are congruent, and 2 and 3 are congruent, what else do we know? Melissa? 1 and 3 are congruent. And if we label our picture, I think it makes it a little easier to see that. So angle 1 is congruent to angle 3. Now we can't know that because of angle relationships yet, because we don't know that A and B are parallel. But how could we know that? transitive property, okay? We can use our transitive property. Okay. So transitive is when two angles are congruent to the same angle. So 3 and 1 are congruent to 2. So they're congruent to each other. Okay? Yeah, cut out the middle one. Yeah. Or you can also call it substitution and just say you substituted 2 for 3 or 1 for 2. Okay? So now, if we know these angles are congruent, can we say these two lines are parallel?
Yeah.
Yeah, how? Are we going to use a converse or a regular one? Converse, we're proving lines parallel. Okay? And then what's our next step to know which converse we're using? What kind of angles are they? They're alternate exterior angles. 1 and 3. Okay, because if we cover up this bottom line to give us a hand in looking at this transversal, focusing in here, we see these two lines cut by a transversal. And so, hey, these are congruent. They're alternate exterior angles, so these have to be parallel.
Quite frankly, I don't like it.
That's too bad.
Wait, they're not well, they call it like
If I cover this
that's
up
obvious.
and we just see this,
No one likes me.
are
That's
these
obvious.
inside or outside these two lines? Okay? Because right now we're just focusing on these two angles. So if I cover this, if I have it like this, it's harder to see. If I cover it like this, it's easier to see that, hey, we're just focusing on this part up right here. Does that make any more sense? Okay, you don't have to like it, but I'm wondering if it actually makes sense. You're just saying that. Okay. Well, I'm sorry, the tone you had made it sound like you were just saying that. I want to make sure you understand. I care about your learning. Okay?
I just.
You don't have to do
Okay,
that.
question on this one. I don't have to do that boys all day. Let's go to number 6 grade, okay?
Just get our homework.
Okay. We're gonna do one more, then we're gonna give our homework. This is another 4-stepper here.
I'm gonna throw up.
Are the givens together?
Don't know why.
Yes, if we do 4 steps, they're together. 5 steps, if they're separate. I'm always gonna do the givens together. Okay? I'm gonna throw up Mr. Cosmos.
That's
Please don't.
gross.
I'm not going to, Mr. Cosmos. So many name changes. Okay. Betsy, I believe you need to tell me my first statement. Mm-hmm. Lights out, okay? Maggie, can I count on you to tell me my first reasoning? It is pretty hard. I knew I could believe in you. Deep down, I knew I could, okay? So let's label these information by the way to help us out. M is parallel to N. 1 is congruent to 2. Okay, Taylor.
There's too many one is
Okay. Yeah, we can do that. Okay. There's a couple ways you can do that. You can do 1 is congruent to 4. If we cover up this, we see 2 parallel lines cut by this transversal. 1 is congruent to 4 because what kind of angles are they? Yeah, alternate interior angles. Okay. So we're going to use the alternate interior angles theorem.
Not the converse one.
Not the converse because we're talking about angles. Very good. Okay. So now, what might be a little more straightforward with our picture, Peyton? Angle 2 is congruent to. That might be factual, but we don't actually know if these lines are parallel. Angle 4. Because we can see that's marked. And because we don't know these two lines are parallel, A and B, yet, we can't use the alternate interior angles theorem. But what can we use because of our first two statements?
Substitution or transition.
Substitution or transitive. Once again, if you say transitive, you don't have to say what you did. If you say substitution, you have to say what you did. You substitute.
That's why we don't do substitution because it's one word.
Sometimes you have to use substitution.
Okay, well, so this
I'm actually gonna speed around one more example myself, so that way you guys can see when we have the substitution. Okay, Jocelyn. Okay. It's actually gonna be the Thursday after Thanksgiving.
That's a long one.
So, time wise, but not class wise.
Oh my goodness,
Okay.
wait, the Wednesday after?
Thursday. Okay. So now, 2 is congruent to angle 4, so we can prove these lines parallel. We're at a point where we can prove these lines parallel because these two angles are congruent. And what kind of angles are they?
Alternate interior.
Yep. And if alternate interior angles are congruent, these lines have to be parallel. What tells us that?
The alternate interior angles theorem.
Very good. Converse of alternate interior angles theorem. Okay.
That's right.
Okay. So
Also, hi, sorry, I'm Brandon.
there it is. Okay. Believe that. Okay. So we also could have gone a different route. If you wanted to go from 1 to 3 using corresponding angles, you could have, and then 3 to 2 using corresponding angles. That'd have been fine too.
Number 8 would be really hard.
Okay. Questions on this one? I'm gonna speed round 7 just so you guys can see what happens here. Okay. So 1, 2, 3, 4 steps, and 4 reasons. I'm gonna speed round through this one just so we can see what happens. M is parallel to M. Angle 1 and angle 2 are supplementary.
Given.
Can mark M is parallel to N. That is given. Thank you, Graydon. Appreciate the help, okay?
I need.
Now we know we're going to be finishing off with our last statement being A is parallel to B, okay? And because we have all of our givens in one, we only have 4 statements rather than 5, okay? So from here, if these two lines are parallel, 1 and 2 are supplementary. Well, we can prove 1 and 3 congruent because they're alternate interior angles. We use the alternate interior angles theorem, not the converse, because we're proving angles using the regular one. Okay, that's because these two parallel lines are cut by this transversal A. Okay, well now if 1 is congruent to 3 and 1 or 2 are supplementary, we don't know that 3 is congruent to 2, but 3 and 2 are what? Supplementary. Now if we're saying 3 and 2 are supplementary, we're actually not using the transitive property here. We're not using the transitive property here. A lot of times transitive substitution can be interchanged, but here's the thing. Transitive property has to change out a whole side of something. Here, we're actually just changing out one little thing. We're just changing out 1 and making it 3, but everything else stays the same. So whenever you just kind of change out one little thing, it has to be substitution. Okay? So we have to say this one is substitution, not transitive. And we have to say that it's angle 1 and you're going to angle 3 that does that. Okay? Now we can prove these lines parallel because if 3 and 2 are supplementary, those are same side interior angles for A and B being the parallel lines, or supposed parallel lines. So this is the converse to prove the lines parallel of, and then we say the angle relationship, which is same side interior angles theorem. Okay. So once again, the reason I showed you this one was so we could see why we have to use substitution at times instead of transitive. Okay. That's the one example we'll have this chapter, but when we have to use that instead of the other. Okay?
Sounds great.
Okay. Let me hand out the worksheet and I have something quick to say about it as well.
Are we not going to do problems?
I don't think you can say.
No, but I'm gonna give some instruction on these proofs. It's actually just like alt proofs. Pretty fun. Okay. I think there's 8 problems here. I'm
Why
gonna
would you let go?
pass James.
Well, I tried to, but you shoved it into my knuckle. It hurt a lot.
So, if we look at this worksheet, guys, okay? The front side proves, back side proves, okay? On number 4, on numbers 4 through 7,
Please tell me that 2 givens count as 1.
okay? On numbers 4 through 7, okay? If you put both givens in one step, you only need 4 steps, okay? So if you put both givens in one step on 4 through 7, you only need 1 step. If you split them up into 2 steps, you would need all 5 on those. Does that make sense?
Yes.
Sure.
Does everybody understand that?
Yes.
Kevin, are you okay?
Yeah.
Okay, does that make sense though? Okay, so numbers 4 through 7. If you put the givens in 1 step, you only need 4 steps. If you put the givens in 2 steps, you need 5. Okay?
4 steps.
And if you forget this instruction and you didn't write it down, or you didn't cross out the 5th step on these, okay, and you forget, you can go back and watch like the last minute and a half of the video and find that too, okay? Right?
Yeah.
Go!
What time is it?
11:56.
Okay.
Or 10:86.
Okay.
Why did you delete one of your videos? I think it was 4.1.